got some questions. What's the energy of an electron in the first energy level?
Oh, didn't we just kind of do this?
Yeah, you guys should be able to do this easy. All right.
So let's see. En is equal to negative 1312 kilojoules per mole divided by n squared.
All right.
And n is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, whatever. So in this situation, n is 1. I don't even need a calculator.
No, we don't. Negative 1312 kilojoules per mole.
So if the electron is sitting in that orbit, which it should be because that's ground state, it's experiencing a negative 1312 kilojoules per mole of energy. Got it.
All right. Now
this one I need a calculator for.
I'm going to change this one.
Oh, you want it fourth?
Okay, so Mrs. G, you've got the energy of the fourth energy level for me?
So that's 1312 divided by 16. That's going to be a negative 82 kilojoules per mole.
All right, negative 82 kilojoules per mole. There we go.
Okay, so the electron sitting in the fourth, it's been excited to get there. It's had to get there, right?
Right.
So something made it jump. Okay, so it's now sitting in the fourth orbit, fourth energy level of the Bohr model, and it's experiencing a negative 82 kilojoules per mole, which based on the Bohr hypothesis is a greater energy than level 1,
Right.
which was more negative.
Right.
Ooh, those negative things are going to drive me nuts. Okay.
Now, watch this next question. It's pretty unstable right now. Going to be unstable and it's going to fall. What's the wavelength of a photon given off by an electron falling from the fourth
to the first, so back down.
So let's see. The change in energy is equal to E final minus E initial, right?
Right. And we calculated final.
Final
number 1, right?
Final being negative 1312 kilojoules per mole.
Right.
And the initial was when it was in the fourth energy level, so that was negative 82.
Correct.
Kilojoules per mole. Now notice this is kind of fun. There's a double negative here.
Yeah.
So it's basically adding,
yeah,
right?
Basic algebra skills.
So change in energy is
1230.
1230 kilojoules.
Negative 1230.
Per
Sorry.
mole. Okay, negative 1230 kilojoules per mole.
Okay, so it's falling back down.
So when it falls down, it loses 1230 kilojoules per mole.
Which would make sense since it's going from a high energy to a low energy.
Right.
Doesn't need all that extra energy, so it expels all that extra energy.
Right. And it gives that off as a single photon. Not as multiple photons, but as a single one.
Okay, but we didn't answer the question. The question wants wavelength.
Right. I was just going to say, what's the wavelength? Well, we didn't answer that yet, huh?
Okay, so we got energy.
So we know it's negative 1230 kilojoules per mole. So where do we go from here, Mrs. G?
Well, I would imagine Planck, because Planck gave us that calculation to, this is multi-step, isn't it? Planck's equation was energy is equal to h times frequency.
Aha. So we can calculate the frequency.
Yeah, let's calculate frequency first.
So negative 1230 kilojoules per mole.
Ooh, we need that one.
We need the version of h that's in kilojoules per mole. Which one was that?
That was 3.98. Yep.
So we need to divide both sides by 3.98 times 10 to the negative 13th kilojoules per mole.
Okay. Frequency 3.09. 3 sig figs, yep. Times 10 to the 15th. 4 sig figs, shouldn't it? No, 3 is good.
3 is good. Because we're only going to use 3 anyhow.
That's per second or hertz.
Okay.
Okay, so there's step 2.
There's step 2. We still don't have the wavelength. We wanted the wavelength. So the wavelength is equal to
C divided,
C divided by nu, right?
Yep.
So 3.00 times 10, let's see, what do I want to use here? Meters per, nanometers? 3 times 10 to the 17th nanometers per second.
Divided by the 3.09 times 10 to the 15th per second.
Hertz and per second, all right.
And you get 97.1 nanometers.
Okay.
Well, definitely not visible range.
That's our answer though, huh?
Yeah.
All right. So what is the wavelength of a photon? That would be 97.1 nanometers.
That was tough to figure out. That was a lot of steps.
That actually incorporated all of what we've just done.
Yeah, pretty much. Speed of light, Planck, Bohr, it's all of them.
It's all in there. All right, now here's the interesting thing. What color is that? 97.1 nanometers.
Not a color.
It's not an actual color.
It's a pretty short wavelength, so it's got to be up in the...
But is it infrared? 97.1?
No, because that's long.
Yeah, that's too long, right? 750 is over here.
It's got to be in the UV-ish.
400's over here, so 97.1 would be kind of UV.
Even way less than UV, yeah.
UV sounds reasonable. Probably
I guess,
somewhere around
yeah,
UV.
UV sounds all right.
Yeah.
Definitely not visible light.
Okay.